Hello students, welcome to mathematics class. Students, this is part 13 of the chapter linear equations in one variable. In this part 13, we will be learning applications of linear equations. As I have already mentioned to you in our previous sessions, solving equations which have linear expression on one side and numbers on the other side. We have even seen one example for applications of this linear equations from the day-to-day life. Now we will continue further with example number 5, where example number 5 is what should be added to twice the rational number minus 7 by 3 to get 3 by 7. So the question clearly is asking you, you need 3 by 7 getting by adding twice the number minus 7 by 3 and there should be some number that which we are about to find. What should be added is this question mark. So to form a linear equation, we need to find what comes in this question mark place. That means what is that number. So we will start our solution by assuming it. Let x is the rational number to be added. So the moment we say x is that rational number which is added, so this question mark becomes x. So 2 times of minus 7 by 3 is minus 14 by 3. To that x is added is giving 3 upon 7. Now we established or we formed linear equation to solve this question. This is the application of this chapter linear equations in one variable. Now how do we solve this? We are very well aware. We want only variable term in one side, rest of the terms to be transposed to the other side of equality. Here this minus 14 by 3 is one way, is a subtrahend, since I can write this as plus x minus 14 by 3, where 14 by 3 is a subtrahend which is subtracted from x, gives 3 by 7. Now by transposing subtrahend to the other side of equality, we will have the other side it acting as a addend. Now 3 by 7 added to 14 by 3, you know how to simplify this. Here LCM is 21, 7 and 3's LCM is 21, 3 3 is a 9 plus 14 7's are 98, gives rise 107 upon 21, which is that number to be added. So we will conclude finally, therefore the number to be added or you can say that to be added is 107 upon 21. Then continuing with the example number 6. Here the perimeter of a rectangle is 13 centimeter. So we have a rectangle. Let's say its length being L, breadth, its width is given, breadth or width we can say here, it is given as 2 integer 3 by 4 centimeter, which means we can say on conversion 4 2s are 8 plus 3 11. So 11 by 4 centimeter we can say, or you can say that even 2.75 centimeter. Here 2 integer 3 upon 4 nothing but 2.75 centimeter. We don't know what is length, we are asked to find that length, but we are given perimeter. So we will start with the assumption, let the length of a rectangle given as L centimeter. Therefore, perimeter is 2 times of L plus this breadth we will consider. So 2 times of L plus B is 13 that they have given already. So by substituting, here arrow mark supposed to come because there is already one time equal sign. So 2 of L plus 2.75 centimeter equals to 13. On distributive property, 2 is getting distributed multiplication over addition. So 2 into L plus 2 times of 2.75 is 5.5 equals to 13. It implies 2 times of L. Your addend 5.5 is transposed. 5.5 is transposed to RHS. 13 minus 5.5, where 2L equals to 13 minus 5.5 is 7.5. It implies L equals to, here 2 is multiplying, if it comes this side it does division, 7.5 by 2, which is nothing but 3.75 centimeter, or you can say 3 integer 3 by 4 centimeter. So students, this is how we solve this question. Now continuing further, question number or example number 7. The present age of Sahil's mother is 3 times the present age of Sahil. So after 5 years, their ages will be added up to 66 years. Then find their present ages. So in this question, we will assume, let the present age of Sahil is Y years. Therefore, the present age of his mother is, since 3 times, so 3 into Y years. Now after 5 years their ages will be, so y will become y plus 5 and 3y becomes 3y plus 5 years. Now sum of their ages after 5 years is 66 years that they gave. From this we can say y plus 5 added to 3y plus 5 gives rise 66. Children, here very important, adding like terms. Y and 3y are like terms, they are added and gives 4 times y. Plus 5 both are like terms, we call constant terms. 5 plus 5 gives you 10 equals to 66. This is the linear equation that we could form. Now on solving this, you know the method of solving. Now we shall do it. Now 4y plus 10 equals to 66. 4y plus 10 equals to 66 by transposing 10 to RHS side, which is addend, becomes subtrahend 66 minus 10, and on simplifying this 66 minus 10, which is 56, now dividing on both sides, divide both sides by 4, we will have 4 into y by 4, 4 get cancels, equals to 56 by 4, 4 1s are 4, 4s are 16, therefore y value becomes 14. Now you can write conclusion. Therefore the present age of Sahil is 14 years and his mother is of, so 3 times 14, 42 years. So this is how we can solve this question, and you are able to understand the application of this linear equations in one variable while solving this sort of day-to-day life questions. Now let us take one more example and discuss. Example number 8. Bansi has 3 times as many rupees, as many, here very important question children, this here the sentence, you understanding it very important here. Bansi has 3 times as many 2 rupee coins as he has 5 rupee coins. Try to observe, he has 3 times as he has 5 rupee coins. Which are those 3 times? They are of 2 rupee coins. Bansi has 3 times as many as he has 5 rupee coins. This 2 rupees coins. Very important, this sentence. Most of us will get confused. Here which coins have got more in number? 5 rupee coins have got less in number and 2 rupee coins have got more in number. That is what you have to understand. Less in number and 2 rupee coins have more in number. So first we shall assume, let us assume the number of coins of rupees 5 as x. Therefore, the number of coins of rupees 2 becomes 3x. Now, if he has all sum rupees 77, that means amount in the form of rupees 5 is nothing but 5 into x rupees, and amount in the form of rupees 2 is 2 into 3x rupees. 5x plus 2 into 3x gives you 6x equals to rupees total 77 what he gave. So 5x plus 6x is 11x. Both are like terms, add it straight away. 11x equals to 77. Write the working steps to solve this equation formed. While solving this equation, 11x equals to 77 can be solved. X as 7 now. Now you can conclude, therefore, the number of coins of rupees 5 and rupees 2 are 7 and 3 times 7 is 21 respectively. So we can say this solution. See children, here you could understand how much important while solving day-to-day problems we have in these linear equations. Then coming to the example number 9. Example number 9. The sum of 3 consecutive multiples of 11. This is also very important questions children. 8th and 9th. Find these multiples. See children, multiples of 11. If you are finding, let's say first is 11, another is, how do you get another? 22, 33, 44 and so on. Now remember, if I say there is one fellow as x and next to that fellow will be 11 more than x, and next to that fellow is 22 more than x. So here assumption is very important. Here the crucial role plays assumption. So let us assume the multiples of 11 as, I can assume x plus 11 and x plus 22. So these are the multiples of 11. Now sum of them, that is added, these 3 gives you 363. Now, like terms of x added gives you 3x. Like terms of 11 and 22 added gives you 33 equals to 363. This is the forming linear equation. Now solving this will provide you answer to this word problem. So you know how to solve. I am transposing 33. You write the working steps. So 3x equals to 363 minus 33 gives you 330. 3x gives you 330. Now here 3 is multiplying, that means multiplicand. If it comes this side, it becomes divisor. Therefore x equals to 330 divided by 3. It implies 110 is the value of x. Now therefore the multiples of 11 are, I say better, let us assume the consecutive multiples. Why? Because here he said consecutive. Let us use it. Let us mention that the consecutive multiples of 11 are 110, 11 more than that 121, and 11 more than 121 is 132. They are added up to gives 363. Students, with this I'll wind up this session. In our next session, we'll continue some more questions of this word problems and exercise 2.2. Till then, take care of yourself. Stay safe. Jai Hind. Thank you.